I want to take a look at a few more coil rule examples here. We'll start off with a fairly straightforward one, then we'll let you do a fairly straightforward one. Then we'll go to one that's a little bit more challenging as a group, and then we'll let you do one that's a little bit more challenging. The first one that I want to draw here looks like this. We've got a piece of steel or a piece of iron or some sort of ferromagnetic material that's got some wire wrapped around it. The wire looks like this. We've got a battery hooked up that looks like this. Which end of the battery is positive? Which end is negative? Left side is positive. We know the left side is positive, the right side is negative, because, Benton, of course, the long side of the battery, in the symbol at least, the long side is positive and the right side is negative. Now, if we're doing electron current here, we could do conventional current if we wanted to, but we might as well choose to do electron current here. Which way would it go? Clockwise or counterclockwise here? Away from the negative or toward the negative terminal of the battery? Away. So the electron current is going to go this way, down in the back, up in the front, down in the back, up in the front, down in the back, up in the front, and around clockwise there. You want to find the polarity of this coil. You're going to take the coil manipulative that you made on Friday, look at the word front, and stick your fingers on the word front, your fingertips, your fingernails on the word front, pointing which way? Which way should they be pointing in the word front, Tim? Yeah. So don't do this, whatever. Take your left hand, put your fingertips on the word front. Do that first, and then bend your hand a little bit. When you do that, your thumb should automatically point to the right. So that means the magnetic field here is pointing to the right. Now, that's the magnetic field inside the coil, which means the polarity of this should be what? What goes on the left side, north or south? South, right? Magnetic field inside points from south to north. Outside, it would point from north to south if we wanted to draw it. But when we do that hand rule, remember that it always finds for us the magnetic field inside. Just remember it's south to north inside instead of what we usually talk about, north to south outside. Okay, I'm going to give you another one here. I'm going to ask you guys to solve this one at your desks. Here's my wire wrapped around there. Here's my battery. Benton, which side of the battery, top or bottom, is positive? The top is positive. Good. So I'll label that for you. I want you guys now to determine the polarity of this magnet. Does it look like this? Or does it look like this? Option A or option B? South and north or north and south? Okay, about 1 minute to solve that question, please. Have a look at this one now. Which way does the current go? Clockwise or counterclockwise? In other words, is it going to go away from the negative or toward the negative? If you're talking about electron current, it's going to go away from the negative, right? If you're talking about conventional current, it would actually go the other way. We'll use electron current and therefore the left-hand rule, the left-hand coil rule. If we chose to use conventional current, that would be okay, but we would have to use the right-hand coil rule instead. Not a big deal. You're going to get the same answer either way. If we use electron current, the electrons are going clockwise here. They're going to go to the left in the back, to the right in the front, and around clockwise back to the positive terminal of the battery. Now, we know which way the current is going. It's going to the right in the front. So take your coil, orient it vertically this time instead of horizontally like it usually is. Put your fingers on the word front on the coil that you made on Friday. They should be pointing on the word front to the right. Okay, that's where my fingers are pointing right now, on the word front to the right. My thumb will automatically point which way? Downward. That means the magnetic field inside this coil is downward. Which pole is this, south or north? Which is this? Sorry. And which one's this? This one's got to be south, right? Why is it south and north? Because we're talking about inside this new magnet as opposed to outside. Always goes north to south outside, always goes south to north inside. Good? Feeling a little bit better about this? Go ahead. Yep. Try this one. This one's harder. This time we have a similar situation where we have a battery, except the battery's not drawn this time, but there is a battery there. The battery is going to either look like this, or it's going to look like this. Sorry, like this, A, or like this, B. I'm going to label this end as the North Pole and this end as the South Pole. This time, instead of finding the direction of the magnetic field, which we have in previous questions, this time we're going to use the direction of the magnetic field to find the direction of the current and therefore the polarity of the battery. Which way does the magnetic field point inside this coil of wire given the polarity of north and south? It's going to point to the left, from south to north. Inside, right? Outside it would point from north to south, but inside we know it points from south to north. So we take our coils that we made on Friday. We look at the word front that you printed right on the front of those coils. And we make sure that instead of sticking my fingers in the direction of the current, because I don't know which way that is, I make sure I stick my left thumb in the direction of the field, which is to the left, from south to north. So thumb to the left. Bend your hand around. Make sure when you bend your hand around that your fingertips point on or are placed on the word front. When they are, which way do my fingers point when they're on the word front? Down. So that means the current in this is down in the front. Now, that is electron current. Had I used my right hand, and I could have used my right hand for this, then I would have gotten the direction of not electron current, but conventional current. Wouldn't be a big deal. It would just, the conventional current would go counterclockwise instead of clockwise. But anyway, you look at it, electron current leaves the negative, goes to the positive. Conventional current would leave the positive, go to the negative, so the battery would be oriented the same way, no matter which hand and which current you used, electron or conventional current. Make sense? So working backwards, instead of saying, oh, look, I know which way my fingers point, which way does my thumb point, this time it's, I know which way my thumb points, which way do my fingers point. All right, let me give you another one. Similar to this. You guys are going to work on this one by yourselves.
We get a break after this one, don't we?
Yep. If this one goes okay, you do.
Yeah.
So make sure it does. So here's the battery again, the missing battery. There is a battery there. It is producing an electric current. You're just not told which way that current is. Now, let me get rid of this so I have some more space. There's another magnet over here. This is a permanent magnet. And this permanent magnet creates a magnetic field that looks like this. Now I want you to determine what this battery looks like. Does it look like this, or does it look like this? Ben says the answer is B. Who says it's B? Who agrees it's Ben? Uh-oh.
No.
Who says it's A? Ben, don't be influenced by all these other people. They may be leading you down the wrong path. You think it's B? Ben, you know what? I'm not sure what it is right now because I wrote this on the board and I don't know what it is until I actually go over it with you guys, but I hope you're right. I hope it is B. All right, how do we tackle this? Well, we know that this permanent magnet over here has a magnetic field that goes toward the right side. That must mean the right side is north or south. South. The magnetic field outside is from north to south. Inside it's from south to north, but outside from north to south. This pole right over here must be what? How do you know it's south? How do you know it repels? Because these field lines aren't joining up there, right? That must mean that there's field lines here that go like this as well, that are going to not join up. This ends up being north. The magnetic field inside goes from south to north. Now it's starting to get a little bit easier. Take the coils that you made on Friday. We know that my thumb is going to point to the right. My fingers have to curl around and touch the word front. My fingertips on the word front. They're going to point which way? Up in the front, yeah. That means current's going to go this way, down in the back. Now what is it? Current's coming around there, leaving this side. This is going to be the negative side. This is going to be the positive side. So my answer is A.
Current always goes away from negative.
Yep. Current always, if it's electron current, it goes away from negative. And how do we know that? How do we know that we're finding electron current in this one? Okay, they use the left-hand coil rule instead of the right-hand coil rule. I could have used the right-hand coil rule. If I had of, I would have found conventional current, and conventional current would have pointed this way. That would have been fine. But we know that the battery still, conventional current goes away from the positive and toward the negative. So we still get the same orientation of the battery, and that was the question, right?